Hi everyone, welcome to week 8 of incomplete data analysis. And in this week, we will start learning about our final topic, and it is multiple imputation. In this first video, we will mainly focus on the early days of multiple imputation and a little bit of its history. And in the next two videos, we will then see how it works, the fundamentals and some technicalities. And next week and the week after, we will get some hands-on experience analyzing data sets and see how to do multiple imputation in practice. So this week it will be more about the methodological fundamentals that we need to then do multiple imputation in practice. But okay, let's get started. Uh, in week 3 and 4 of this course, we have learned about single imputation, and specifically, we have covered mean or unconditional mean imputation, which by now we know it's the worst method that we have learned so far to deal with missing data. So of course we will not come back to this. And then we have learned about regression imputation, stochastic regression imputation, and hot tag imputation. And we have seen that stochastic regression imputation is a quite promising approach. In fact, we have done a simulation study in week 4, and stochastic regression imputation performed well, apart from the known problem, it's a single imputation procedure, so we know that standard errors are too small, and this was reflected. We have studied this in terms of the coverage of the confidence intervals. So the resulting coverage was below the nominal level. And we have also, or you have also studied in the assignment, a very simple form of predictive mean matching. And in fact, predictive mean matching is also a very good or promising approach. Of course, not the plain vanilla version that you have studied in the assignment, but there are refinements of such approach. And as we will see, it's a good approach. But stochastic regression imputation or predictive mean matching, as good as they suffered from the problem that they were single, or we have learned them as single imputation methods. And we know that even the best methods, as stochastic regression imputation, which we have studied in detail, it suffered from the fact that the resulting statistical inferences were not valid. And basically, and we have talked about this when we are replacing the missing we have a missing value, and when we are replacing the missing value by a single imputed value, we are somehow pretending that we are certain about such value, right? We just replace the NA, say, in our data set by an observed value, and then we go ahead with our analysis, and it seems that I had a missing value, I have replaced, and now everything is fine. And we know it is not. And I have here this uh, quotation from Rubin, and basically he says that what we have discussed about single imputation, imputing one value for a missing datum cannot be correct in general because we do not know what value to impute with certain. If we did, the value would not be missing. And I think that this sentence summarizes the problem of single imputation. But okay, single imputation, or at least stochastic regression imputation, was already quite good. So if we can fix it somehow, then it would be a good technique for dealing with missing at random data, correct? And basically, this is what multiple imputation proposed. So don't replace each missing value by a single imputed value, but replace it by several imputed values. So what we do in multiple imputation is we have our original data set, we have missing values, and we create several copies of our original data set. Say 3 copies of our original data set. So we have 3 data sets with missing values, and we will impute for each data set the missing value. So at the end, I have three collection or 3 data sets with imputed values. And then I perform my analysis of interest in each of the completed, say, data sets. And then at the end, of course, I will not report the analysis from each data set. Say, okay, if I have used these data sets, then my final estimate is this. But if I use this one, then my estimate is this one. Of course, this is not what we do. And we will learn in the next video how then having analyzed several completed, say, data sets, completed because we have imputed the missing values, then what has to be done to come up with a final estimate. And this is the so-called Rubin rules to pull or to combine the results, but we will see that in the next video. And here, this is a scheme of how multiple imputation works, and we will come back to this figure in the next video when we talk about each of the steps of multiple imputation in detail. But just to give an idea, so we start with our incomplete dataset, our original dataset that has some missing values. Then we create several copies of our dataset. In this case, in this scheme, we have created 3 copies of our dataset, and for each of the copies, we impute the missing value. So what we have done before in single imputation, here we would be doing this 3 times. One for each copy of the dataset that we have created. And then we have 3 completed datasets here. And when we go here, we do our analysis of interest, the analysis that we would have done in case we had no missing values. In single imputation, we have done that just a single time, and here we need to do it as many times as copies of the data set that we have made. And at the end, we need to combine our results. And this is, we will do it, or everyone does it using the rules for combining the results that Donald Rubin proposed in the 70s or 80s. Okay, but we will come back to this figure in the next video, where we will talk about each of these steps in detail. I can say that the tricky part of multiple imputation is how to impute well the several how to impute the values or in the several copies of the dataset that we have made, because then step 2 is just to perform the analysis that we were interested in several times, and step 3 we combine the results, but we have expressions for that, so there is no rocket science there. But step 1, this step here of imputing the missing values, is important, but we will go there in the next video. So let's talk a little bit about the history or the early days of multiple imputation. I think it's important to understand the context and to know a little bit about it. So, and this is basically almost copy and paste from the text that is in the book by Van Buren, a book about multiple imputation. Is the author of the mice package, and we will be using mice package in the next lectures. And the book is this one, Flexible Imputation of Missing Data. It's on our reading list, and I'm pretty sure, I'm almost certain that you can access it online through the library. Okay, and multiple imputation, it was developed by Donald Rubin in the 70s. So Rubin is basically every topic that we are covering here. Rubin made the fundamental contribution. So he was the one coming up with the designation or the classification of missing data in missing completely at random, missing at random, and missing not at random. Then we have also the distinction between missing data mechanism and missing data pattern. Then we have learned recently about, in the last couple of lectures, about the EM algorithm and the seminal paper where the EM algorithm is formalized. Donald Rubin is one of the authors, and now finally we are learning about multiple imputation, and Donald Rubin was the creator of multiple imputation. But the birth of multiple imputation, it was developed by Don Rubin in the 70s, and the birth of multiple imputation has been documented by, and now I think the name is Fritz. It looks like a German name, but the person lives in the US. I will say Sharon. I'm pretty sure that I'm not pronouncing the name correctly, but okay, that's not too important. But in 2004 or 2005, this author, Fritz Sharon, he published a paper in the journal American Statistician, and the title was Multiple Imputation, How It Began and Continues. And we have here the cover of the paper. It's like a two-column style paper. So if you come from this column to this column, it will not match, but that's not important. If you are interested, you can just Google and access the paper. I have not uploaded it to learn. But important point is the birth of multiple imputation was documented in this 2004 or 2005 paper. And it's interesting because it basically tell us that how multiple imputation, or what was the underlying problem that somehow prompted the development of multiple imputation. And basically multiple imputation was developed as a solution to a practical problem with missing income data in the March income supplement to the current population survey. And in 77, this person, Soros, he was working in the US Census Bureau, and they faced that problem of missing income. And by that time, they were using a simple hot deck procedure, and I think they still use hot deck, but a more advanced hot deck nowadays. And basically, he noticed that the variance could not be properly calculated. So basically, they were using hot deck imputation, a simple one, a single imputation, and by hot deck. And he realized that the variance was not correctly calculated. And apparently, he knew Donald Rubin, and he asked Donald Rubin what could be done instead. And Rubin came up with the idea of using multiple versions of the complete data set, something that he had already explored earlier in the 70s. And according to Shorn, he said that the paper is the beginning point of a truly revolutionary change in our thinking on the topic of missingness. Basically, the paper that Rubin has published in 1977, I think. And Rubin observed that by imputing a single value, the variance could not be correct in general. This is not new for us now. And he also needed a model to relate the unobserved data to the observed data. And this is what we have been doing in regression imputation and stochastic regression imputation. And for instance, predictive mean matching also use this idea. And his solution was okay. So we know that we have problems just by imputing a single value. So why don't we create multiple imputations that they reflect the uncertainty that we have about the values that we are imputing? And in his 1977 paper, he explained how to choose the imputation models and how to derive the imputations. And this was basically the beginning of multiple imputation. He had published a paper in 1977, sorry, and it was possibly a quite technical paper knowing Rubin's work, and I think it was popularized after it was after multiple imputation, and the ideas that Rubin has developed were put in practice by the practitioners. And over the years, multiple imputation has been sometimes unfairly or harshly criticized. For instance, this author Fay in 1992, he pointed out that the validity of multiple imputation can depend on the form of our subsequent analysis. So basically, he said that depending on the model or on the analysis that we are interested in step two after imputing the missing values, that multiple imputation cannot in certain situations, multiple imputation is not a valid approach, and it produces some counter examples, and it's with quotation marks because in fact they were not counter examples because they had some flaws, but he came up in 1992 with some counter examples in which multiple imputation systematically understated the true covariance. So basically the same problem that we would have with a single imputation method. And he concluded that multiple imputation is inappropriate as a general purpose methodology. But fortunately, Shaoli Meng in 1994, he showed that the counter examples that Fei have produced and that were on the basis of its recommendation of not using multiple imputation as a general purpose methodology, they had some flaws, and we will come back to this in the last video of this week. But basically in our imputation models we need to preserve some relationships that are that we will be used later in our analysis model. For instance, if we have several variables, and if we in our analysis model, if we include an interaction, say between two variables, then that interaction should also be present in the imputation models. And this is just one example, and basically Fay, it didn't have these details in consideration, and that's why he concluded that multiple imputation was not good. In a certain sense, it was not bad that he he pointed that problems, because then people working in multiple imputation, they realized that it could be a problem, but there are ways you can fix it. So it was possibly it was an unfair criticism, but I think it led to fixes, and nowadays we do better multiple imputation also because of him. And basically, summary, 40 years later, or more precisely, multiple imputation was developed. The first paper about multiple imputation by Rubin it was in 1977. So today in 2020, 43 years after the birth of multiple imputation, it's basically accepted as the best, or one of the best, if not the best method to deal with missing data in many fields. And in fact, multiple imputation, it most of the time acts as the benchmark against new methods are compared with. So every time, or most of the times that someone comes with a new method for dealing with missing data, comparisons with the result that would have been obtained using a form of multiple imputation, because there are hundreds of ways of doing multiple imputation, they compare with a form of multiple imputation. So I think multiple imputation, it's a very interesting and useful methodology to learn. And this is there is also a book on multiple imputation that came out in 87, and the title is Multiple Imputation for Non-Response in Surveys. As we have seen, multiple imputation, its roots are in the surveys area, and as we have talked about this at the beginning, it's an area that is very prompt to the occurrence of missing values. And this is a classical book. I have my own copy here. It's kind of second hand copy, so it looks like old. Don't try to guess my age by how old this book looks like. It's a second hand copy, and the this version of the book on Amazon, it's over 100 pounds. So it's kind of expensive, but there are secondhand copies which are good and much less expensive. But that's not important. Okay, that's the first book on multiple imputation. There are others. I've shown you at the beginning of the video one of the best books on multiple imputation, the one called Flexible Imputation of Missing Data. This book is also in our reading list and it's available for free in the library. It's called Applied Multiple Imputation. It came out uh, this year, I think in April or March. And there are also then specialized books about multiple imputation in clinical trials and longitudinal studies, basically on the field of biostatistics. And this is also an image that it's available in the book by Van Buren on flexible imputation of missing data. And it's an interesting plot or graph because we have it's basically a multiple imputation at the age of 40, so it counts the log of the number of publications over the years, and we have three series here. The black dots, this series, it's the number or the counts on early publications about missing data, right? So here we have Rubin's paper and possibly something else and some other early papers. This with a square, so this series here, it's papers. This was a search made on Scopus. It's like a kind of Google, but for publications. We also have Google Scholar, but they used Scopus. And this series here on the right, it's papers that contain the words or the two words multiple imputation in the title, and these are most of the times like methodological papers, so authors proposing new methods for multiple imputation. And the middle series here are papers that have multiple imputation in the abstract of the paper. So the abstract is a short description of the paper, and this can be both or methodological papers or applied papers that they analyzed some data and possibly they had missing values and they have used multiple imputation. And we can notice that this middle series here, we have here, it's the number of publications, but it's on the log scale. And here we see that we have almost a linear trend. So this means that on the original scale, this is like an exponential growth in terms of the number of publications about multiple imputation applied or to the logical one. So it basically the message here is that multiple imputation is still a very active area of research, and at the same time, it's used by the practitioners, so it's not like a dead field. And I've just said this and this, and also in addition to the articles and books about multiple imputation, there is also several software packages that implement multiple imputation type of procedures. And here I have a screenshot of several R package that implement different forms of multiple imputation. We see, for instance, this is one of the first ones, Amelia, and we have mice here. We will be using mice, and Vim. We have used this at the beginning for visualization. It also has some multiple imputation procedures implemented in this package. And basically, we have this long list, and the list is possibly longer because this was the screenshot. I've made it like a couple of years ago, and possibly in the meanwhile, we have new package, and maybe some of these were already removed from CRAN, but main message is that there are several statistical software available for conducting multiple imputation. Of course, I think we should use the software. If the software is available, there is no need for us to code everything from the scratch, but we need to understand what the software is doing. And this is also the screenshot of a cover of a paper in Journal of Physical Software. Journal of Physical Software is a journal dedicated, as the name says, to statistical software. Nowadays, it's mainly about our package that were developed. In the past, it also contained some SARs and stata macros, and this was a special issue about software developed for multiple imputation, and the name was State of the Multiple Imputation Survey, and this was in 2000. This was published in 2011, and in this collection of articles, we have the article describing the mice package that we will be paying attention next week and the week after. And I've uploaded two papers to learn. You can have a look at them. And the first one was a paper that was written by Don Rubin in 1996. So it was the title Multiple Imputation After um, 18 years. In fact, it was after 19 years. And I think it was it is an interesting paper, at least like the introduction and the abstract. Then it has some technical details that maybe you can skip, but at least I think the abstract and the introduction, it's an interesting reading. And also a paper that came out more recently, 2 years ago, in the journal called Statistical Science, and the title is Multiple Imputation, a review of practical and theoretical findings. And if you go over the introduction, we will find a lot of concepts that we will be covering in the next two videos, and also some concepts that we have covered in the past lecture. So this is everything for the history, or just how multiple imputation was, what was the motivation for multiple imputation. And in the next video, we will see how to formally conduct every of the steps involved in multiple imputation. So see you in the next video.